All right, let's talk about something that's key to making any web app feel just snappy, instantaneous. It's not magic, it's actually something powerful, but a lot of people get it wrong: web caching. We're going to break down exactly how to do it right.
I mean, you've totally felt this, right? You click on one web app and boom, it's just there. But then you go to another one and you're just staring at that little spinning icon, waiting. What's the deal? Well, almost every single time, the secret sauce is a really smart caching strategy. So, if we're going to talk about performance, we have to talk about the main villain of our story, the network trip. Think about it. Every single time your app needs anything, a file, an image, a little piece of data, it has to go all the way to a server and come all the way back. And every one of those trips is a gamble. Is the network fast today? Is it even reliable? It's a huge bottleneck.
So, how do we fight back? How do we beat this villain? Well, it's not about one single trick. It's about building a powerful three-layered defense. Seriously, think of it like building a fortress around your app's performance. Each layer is a wall that solves a very specific problem.
So here's the game plan. We'll start by looking at why apps feel slow, then we'll build our fortress, layer by layer. First, aggressive caching, then smart validation, then we bring out the big guns, the service worker, and finally, we'll put it all together into your ideal caching setup.
All right, let's dive into layer one, aggressive caching. This is the foundation, and it's all about using cache control. This is our first and, honestly, one of our most powerful lines of defense. It's built for all the parts of your app that, don't really change that often. The goal here is simple. Tell the browser to grab these files once and then just hang on to them for a long time.
So what kind of stuff are we talking about here? Well, think about the absolute core building blocks of your app. Your JavaScript bundles, whether you're using React, Vue, Angular, whatever. Your CSS files that make everything look pretty, all your images, fonts, and icons, even static JSON or WASM tiles. These are all things that really only change when you push out a whole new version of your app. And this right here is the magic command. This one header is the instruction we give the browser. Let's break it down. Public means any cache can store it. Max age equals 315360000. That's a lot of seconds. It's basically telling the browser to cache this file for 1 full year. But the real kicker is immutable. That tells the browser, hey, I promise you, this file will never change. So for the next year, don't even bother asking the server about it. Just use the one you have. Okay, so you're probably thinking, wait, if I cache my files for a year, how on earth do I ever push an update? And that is a great question. This is where modern build tools are so clever. During your build process, your framework, React, Vue, you name it, doesn't just create main.js. It creates a file with a unique hash in the name, like main.8f3a12.js. When you deploy a new version, that hash changes. So the browser doesn't see an updated file, it sees a completely new file name. And because it's a new URL, it knows it has to download it. It's such a simple and elegant way to handle updates. So this cache it forever strategy is amazing for our static assets, our JS and CSS. But there's one super important exception, the index.html file. You have to treat this one differently. Why? Because the HTML is like the map. It's the file that tells the browser which specific hashed versions of the JS and CSS files to go and get. If we cache the map for a year, the user will never see our updates. So for the HTML, we use cache control no cache. And this is a bit of a tricky name. It doesn't mean don't cache it. It means, hey browser, you can cache this, but you must check back with the server every single time to see if there's a new version before you use it. Okay, that brings us to layer 2, smart validation. This is all about being efficient with e-tags. This layer is perfect for all those resources that might change, things like API responses, or that index.html file we were just talking about. The whole point here is to avoid re-downloading a massive file if we absolutely don't have to. And the magic tool for this is called an e-tag. The best way to think of it is like a fingerprint for a resource. When the server sends you a file for the first time, it also sends along this unique fingerprint, this e-tag. Then, the next time the browser needs that file, it sends that fingerprint back to the server and basically asks, hey, is the file with this fingerprint still the latest and greatest? Or do you have something new for me? And here's the beautiful part. If the file on the server hasn't changed, if it has the exact same fingerprint, the server doesn't waste bandwidth sending the whole file all over again. Instead, it just sends back this tiny, super efficient response, a 304 not modified.
It's just the server saying, yep, what you already have is perfect. You're good to go. Use your cached version.
And what is the payload for that 304 response? 0. 0 bytes downloaded. The browser just gets that tiny confirmation and then bam, instantly loads the file from its own local cache. That whole round trip is so incredibly fast that to the user, it feels just as instantaneous as if it were fully cached. It's a massive win for performance. So where does this E-tag strategy really shine? Well, it's perfect for things like API responses, that index.html file, or any kind of dynamic JSON. Basically anything that changes from time to time. But here's the crucial thing to remember. You absolutely should avoid using E-tags for your hashed static assets. Why would you? We already told the browser they're immutable. Adding an E-tag check would just be adding a pointless network request we've already designed our system to avoid.
And now we get to layer 3, the service worker. This is the ultimate guardian for your app. If the first 2 layers were about setting rules, this is where we get full programmatic control. A service worker is basically a chunk of JavaScript that sits between your web app and the network, acting like a super smart proxy. It lets you intercept every single network request and decide exactly what to do with it. It's incredibly powerful.
And because we have this control, we can implement really sophisticated caching strategies. We can go cache first for things like images and fonts, just grab them from the cache, don't even bother the network. We can go network first for API data that absolutely has to be fresh, but maybe fall back to the cache if the network is down. And then there's my personal favorite, stale while revalidate, which is an absolute game changer for things that feel like live data. And of course, you can always go network only for things like authentication, or cache only for assets you need to work offline.
Let's just double-click on stale while revalidate for a second, because the logic here is just brilliant for user experience. Here's how it works. The second your app requests some data, you instantly serve the old version you have in the cache. Right away. The UI appears, the user sees content, they're happy. Then, in the background, the service worker goes and fetches the fresh version from the network. When that new data comes back, you just quietly update the screen. The user gets the best of both worlds, an app that feels lightning fast with data that never gets too old.
Okay, we've seen all 3 layers of our fortress. Now let's put it all together and build your ideal caching setup. First up, your static assets, your JS, your CSS, your fonts. This is pure layer 1. You're going to use the cache control header with a massive max age and immutable. Your build tool, like Vite or Webpack, will handle the file name hashing. And you absolutely do not need E-tags for these. Just set it, forget it, and let it work. Next, your main entry point, the index.html file. This is a job for layer 2. You'll set the header to cache control, no cache. Remember, that means revalidate every time. Then you use E-tags for that smart validation. This setup guarantees that the user always gets the freshest map to your application's assets without re-downloading it if nothing's changed. And finally, your API responses. This is where we get fancy and combine layer 2 and layer 3. You'll still want cache control, no cache, and E-tags for that basic validation. But then, you let your service workers step in to apply a more sophisticated strategy. You might choose network first if the data has to be absolutely up to the second, or you could use stale while revalidate to give the user that incredible feeling of instant on performance. So after you put all this in place, what's the payoff? Oh, it's huge. We are talking about dramatically faster load times. We're talking about lower server costs because you're just not sending as much data over the wire. Your Lighthouse and other performance scores are going to go way up, but more than all that, you get an app that just feels solid. It feels instant. It feels resilient. And you even unlock the door to making parts of it work completely offline. So I want to leave you with this final question. Your app is fast, but is it resilient? Because look, speed is awesome. It's what gets people excited. But when you truly master these layers of caching, especially with a service worker, you're moving beyond just making a fast app, you're building a resilient one. An app that can handle a shaky connection on a train or even no connection at all. And that right there is the mark of truly exceptional engineering.